Hey guys, we're going to learn about our second type of factoring today. So we learned about GCF factoring already, and now we have some formulas. So the first formula is difference of two squares right here. So you will have to memorize these for the test and for the SOL. They are not given to you on a formula sheet, but they are going to be on the back of the classroom for when we are in class time. So if you think of a perfect square is like 9 because 3 times 3 is 9, or 25 because 5 times 5 equals 25. So that's why it's called that. And that's why the a is squared and the b is squared. The a minus b and the a plus b right here, that's your final answer. So the first thing you got to figure out when you're looking to solve these is to figure out what the a and b are. So to find a and b, what you do is you square root both terms. So you can do that on your calculator by just hitting second x squared. All right, so if you didn't know how to do that, let me show you. So if I wanted to find, if we're looking at problem number 1, if you see that 81 there, so how do you find the square root of 81 is you hit the second button, the blue button, and then x squared is in the same column, and then you just type in 81, and it is 9. If you do not get an even number when you do this, it means you've done something wrong, maybe chosen the wrong formula, or forgotten to take a GCF out. So b in this case is 9 because I square rooted that 81. Now I got to square root x squared. You just got to use your brain for this one. The square root of something squared is just the variable, so x. So then once I figure out what a and b is, I just plug it right into that formula right here. So I plug in whatever a is here, whatever b is there. So I write it out like this. A minus b, a plus b. And that's my answer. All right, for the next one, when I square root the first term, I get x. The next one, you can use your calculator, but I'm going to just tell you it's 16. This one has a y with it as well, y squared, so I make it y for my b. I fill it in, a minus b, a plus b. And that's your final answer. You're done. Couple more. This next one, it has the GCF you have to pull out first. The first two, I didn't talk about it, but there was no GCF in those. So we're going to go back to the day before's lesson. So 36 and 4, you got to find the GCF of that. So the GCF is 4. So off to the side, I'm going to just perform a GCF problem that you should know how to do at this point. So I take a 4 out. All right, 36 divided by 4 is 9. And 4 divided by 4 is 1. All right, so then what I do is I'm just going to take that GCF and I'm just going to put it right on the answer line. And then I'm going to forget about it. And so I now need to not even pay attention to this original problem. And I am now solely focused on this new problem that's been created in the parentheses. So I'm going to square root both terms. So the square root of 9x squared is 3x. And the square root of the 1 is 1. So then I fill it into my formula, a minus b, a plus b. Done. All right, number 4, it doesn't have a GCF, so I'm going to see if I can square root that. Now it's next to the 4th, so it's a little weird. So when I square root that first term, the square root of 16 is 4, and the square root of x to the 4th is x squared, because x squared times x squared is x to the 4th. So that's where I get that. And then I square root with 1 and I get 1. So I fill it in. Now this one has a step further you need to go. The reason why is because whenever I just did that formula, I am left with a problem that I can square root again. So I can actually square root this junk all over again. So square root of 4x squared, so I'll go off to the side. The square root of 4x squared is 2x. And the square root of 1 is 1. So I can take that new a and b and I can fill it in to the same formula, a minus b, a plus b. Okay, and this second one, the second parenthesis here, Now, there's a plus sign in between it. So if you see it has a plus sign. When it has a plus sign in between it, you can't do the A and B. So this guy just comes on down in your answer. You can't make it 2x minus 1, 2x plus 1, or anything like that. So my final answer for this one is these 3 parentheses, because this guy became those 2. So that's gone, and it's become these 2. And then this one just comes straight down. Our second formula is difference of 2 cubes. So if you notice, this time we have cubes, because we're talking about perfect cubes this time. So to find A and B, you might be able to figure out that instead of square rooting both terms, you cube root both terms. So you may not know how to do this in your calculator. So let me show you that, and I suggest you copy down notes if you didn't already know how to do this. So if I want to find the cube root of like that first problem, 8, what you do is you hit math 4. So math is below the green button, and then you should see the cube root there, number 4. And now I plug in 8, and I get 2. All right, so you cube root both of them. So we already cube rooted the 8, so the b is 2. The cube root of x cubed is just x. So our formula this time is a little bit longer. It starts off the same, a minus b. But then if you notice that second parenthesis is kind of ugly. So the first thing in the second parenthesis is a squared. So a is x, so x squared, plus. The second thing is ab, so I multiply a times b, so x times 2 is 2x. And the last thing is plus b squared, and b is 2, so 2 squared. And you want to actually square this b. So 2 squared is 4. That's my final answer. I don't have to do anything else. All right, for the next one, we have some big numbers. You want to check to see if there's a GCF, and I'm going to tell you there isn't. And so I go straight to cube rooting it. You can use your calculator like I showed you. The cube root of 343x cubed is 7x. And the cube root of 64y cubed is 4y. I plug it in. So a minus b, it starts off normal. Okay, I have to go down to the bottom. Then it says a squared. So when you square this a here, when you square 7x, you need to make sure that you're squaring the number as well as the variable. So I have to take this whole 7x, and I have to square the number and the variable. So what goes in here is 49, because 7 squared is 49, x squared. Plus, the next part of the formula is a times b. So you want to actually multiply them together. 7x times 4y, 7 times 4 is 28, and you still have the xy. Plus b squared, again, when you're squaring the b, it has to be, you have to square the number and the variable. So 4 squared is 16, y squared. That's your final answer. Kind of ugly, but that's it. You don't have to do anything else. All right, our last formula is now sum of 2 cubes. It's extremely similar. So to find a and b, you do the same thing, cube root both terms. So x cubed plus 64. The cube root of x cubed is x. The cube root of 64 is 4. So I fill it in. A, now this form is a plus b, so x plus 4. A squared, x squared, minus a times b, 4x, plus b squared. B is 4, so 4 squared is 16. Number 8, this one has a GCF. So the other ones didn't, so I didn't bother mentioning it, but this one does. So off to the side, it has a GCF of 2. I divide both of these by 2. I get x cubed plus 125. So I take that GCF and I put it right on the answer line, and I forget about this problem, and I solely focus on this new problem inside the parentheses. So I cube root both terms, so I get x, and I get 5. So I fill it into my formula, a plus b, a squared, minus a times b, 5x, plus b squared, which was 5 squared, 25. All right, now I put 2 more on the bottom because I want you to be able to figure out when you use what formula. So like this number 9, if you see 2 cubes, you're going to be using one of the longer formulas. Now, the way you know which of these cube formulas to use is because this one has a minus in it, and this one also has a minus in it. So since those are both minuses, you're going to use the difference of two cubes instead of the sum of two cubes. If it had a plus sign, you use the sum of two cubes. Now, if these were squares instead of cubes, then you would use the difference of two squares. All right, so since I am using the difference of two cubes, my a, I'm going to do these really quick. A is 2x, b is y. I cube rooted both terms. So I fill it in, and the formula is not up here, but hopefully you have them on your paper right in front of you. So it is a minus b. When I square the a, I square the number, so 4 and the variable squared, plus a times b, so 2x times y is 2xy, plus b squared, which is y squared. That's your answer. Last one. So when I square root the first term, it is 3. I square the second one, it's x. So this is weird because the number's first, and that's unusual. So I put the number first. It's a minus b. Then it's a squared, so 9, plus a times b, so 3x, plus b squared, which is x squared. So if the number comes first in the problem, it'll come first whenever you're writing out the formula.